Hello, this is Mohit Chikadi. I'm from Mechanical Engineering 7 semesters. This will be my presentation for the Robust Engineering course. Under the guidance of Dr. Bharti sir, I have done the following experiments. Please let me share my screen so that we can go ahead. Hello. So the topic I've chosen is elemental composition and cost analysis of veterinary calcium supplements. So every veterinary supplement consists of essential minerals and vitamins that support animal health. So you have, calcium that strengthens the bone. You have magnesium that increases enzyme action, and zinc and other, metabolic actions. The concentration and composition of these elements influence the effectiveness and the absorption rate and the cost of the supplements. So understanding this relationship between the elements, and the pricing will help us understand the veterinary calcium formulas. So the problem that we are facing was that the cost of raw materials was a major factor in the pricing of the veterinary supplements, and optimal pricing is needed. So optimizing the elemental consumption that can help reduce the costs while ensuring that necessary nutrition benefits are there for animals. So a systematic approach is needed to determine the ideal balance of essential elements and minimizing the costs without compromising the efficiency. So these were the elements that we have chosen. We have calcium, we have magnesium, we have zinc. And in the data set and the input variables, we have the supplements like Ascal Gold, Pravical Fort, Calcimist Gold. You have Kal Shakti and yeah, like 18 other medicines that we have taken into consideration. And the elemental composition is the amount of calcium, magnesium, zinc, and vitamin D3 in each supplement. And we have the cost per gram. So that is the price of the raw material per gram. And then you have the total contribution to the cost. So that will be the final impact of each element's concentration to the supplement's overall price. So moving further, this is the data set. As I told you, have Kal Shakti Platina, Osomen, M&M, Milky Cal, and so many other medicines. And then you have calcium, vitamin, magnesium, zinc, and the average price that the seller sells it in the market. This data, we'll be using a couple of different data analysis techniques to uncover some potential surprising insights. So stick around. What is regression analysis? So, uh, uh, so I'll just stop sharing my screen and then I will share the mini tab application so that we can understand what is happening. We can see that there are already some analysis that we have made. We will delete this so that we can start the analysis fresh. And here, as you can see, I've already uploaded the data set, and we'll go ahead and start with the analysis. To start with, we'll use a statistical method called the regression analysis. Simply put, regression helps us see if one thing like price can predict another like material content. Imagine you're trying to predict a student's exam score based on how many hours they studied. So regression helps us draw a line that best represents the relation between study hours and exam scores. In our case, we want to see if there is a similar relation between the price and the supplements and the amount of minerals it contains. We'll be looking at a few key things from these analysis: the regression equation, which tells us the nature of the relationship, the R square value, which indicates how well price predicts mineral contents, and the P value, which tells us whether the relationship is significant. Uh, so we will go ahead and start the analysis. We'll go to statistics, regression, and then regression again, and then fit regression model. Here, we will need to choose the columns that will be our responses. So we select the responses, then we come back and we select the average price as our continuous predictor, and then we press OK. Now this gives us four regression models. So we'll look into each of these regression models. Okay. So we know that the R square value ranges from 0 to 1, that is 0% to 100%. and with higher values indicating a stronger relationship, uh, and a value of and a value of 1 means that the model perfectly predicts the outcome, and while 0 means it's a terrible predictor. And also look, the p-value, you know uh, it has a statistical significance. If the p-value is less than 0.05, the result is considered statistically significant, meaning it's unlikely to have occurred by random or by chance. So we will go ahead and we look into the analysis of calcium that we have done. So as you can see, starting with calcium, our analysis gives the equation of 3335 plus 7.01 into the average price. This equation suggests that theoretically, as the average price increases, the calcium content should also increase. For every increase in the price, we should expect to see around 7% increase in calcium content. However, the R squared value that we have is only 10.77%. This is extremely low. It means that the average price only explains about 10% of the variation in calcium content, which is next to nothing. It's like saying that only 10% of the students' exam score is determined by how much they study, which is a terrible correlation. Also, the p-value, came out to be 0.184. Here we can see the p-value. P-value is greater than 0.05 is considered statistically insignificant. Therefore, the relationship between the average price and the content of calcium is negligible, and there is next to no relation between the two. So next we will go to the vitamin D3 analysis versus the average price. Uh, the regression equation that we found here was 19471 plus 26.8 into the average price uh, in Indian rupees per liter. Again, this suggests that theoretically the higher priced medicines would have more vitamin D3. However, similar to calcium, the R squared value is shockingly low, such that 4.04%, which means the price is a terrible predictor for vitamin D3 content. The p-value here is 0.424, meaning it is statistically insignificant. So we can confidently say that there is no apparent relation between the price of the medicine and the content of vitamin D3. Uh, okay, so next we will go ahead with magnesium. Magnesium, we can see that the equation that we got was 68.5 plus 0.218 into the average price. This time the R squared value is a bit better, 33.16 percentage. This means that we can better predict the content of magnesium using the average price that we could vitamin D3 or calcium. Still, about 67 percentage of the variance is due to something else other than the price. The p-value is 0.012, as we can see over here. Therefore, the correlation between the average price and the amount of magnesium in the medicine is statistically significant. We can then go to the zinc. So finally, let's analyze the zinc. The equation is minus 2. So minus 2.5 plus 0.0511 into the average price. The R squared value is 33.96 percentage. This is about the same as it was for magnesium. The p-value is 0.011, which is less than 0.05, meaning that we can infer that a change in the average price will statistically mean a change in the content of zinc. Yeah. What was the takeaway that we had? While the regression analysis did suggest that there was a relation between the average price and the content of magnesium and zinc, the R squared values are fairly similar. This indicates that there are other factors contributing to the amount of these minerals in the medicines besides just the average price. It's like saying that the price only tells us small part of the story. So it is vital. It is vital to note that the correlation is not causation, meaning that even though there seems to be a statistical relation, it doesn't necessarily mean that one causes the other. Maybe a brand is more expensive because marketing, even it doesn't necessarily have more minerals. So we need to look into other possible factors influencing the price, like brand reputation, manufacturing costs, distribution channels, packaging, marketing, perceived value, etc. So it's important to remember that this is just one analysis. It's not intended as medical advice, and always consult the healthcare professionals or personalized recommendations. Also, data can only tell you what you need to know. So maybe there is non-statistical reasons for the difference in pricing. I'm not a medical profession, and this video is for informational purposes only. Always consult with a qualified healthcare provider for any health concerns before making a decision related to your health, related to the cattle health or treatment. Now let's switch gears and dig even deeper with another powerful technique called the principal component analysis. So we will go back and I'll share the screen again. We'll go back to mini tab. So here, uh, we will go to statistics. We will go to multivariate, and then we'll go to principal components. Then we'll select all our components, and then we press OK. Now imagine we have a data set of different medicine brands, each with varying amounts of calcium, vitamin D3, magnesium, and zinc, along with their average prices. Analyzing this directly can be overwhelming. So PCA helps us reduce the number of variables while retaining most of the important information. Think of it as finding the key ingredients of or ingredients that defines each medicine. So the more variables you have, the harder it is to find meaningful patterns. So PCA helps us overcome this by reducing the number of dimensions. Uh, yeah. So now let's look at the results. The first part we have here is called the eigen analysis. First off, eigenvalue shows how the amount of variance explained by each principal component, that is PC1, has the largest eigenvalue, that is 2.4988, indicating it explains the most variance. So the proportion of variance explained by each PC, our first principal component PC1 explains a huge 50% of the total variation in the data. So this PC1 tells us that 50% of the story. We are therefore able to account for half of the variation in the data by looking at single variable PC1. So cumulative shows the cumulative proportion of the variance explained as you add more PCs. The first two PCs explain 75.9% of the variance, and the first four explain the 97%. Imagine you describing a person instead of listening to every single detail like height, weight, hair color, eye color, etc. You could just summarize them with a few key characteristics: overall build, dominant features. So PCA is doing something similar to that data. So uh, you know uh, now understanding the eigenvectors, the real magic happens in eigenvectors sections, so also known as the component loading. These values tell us how much each original variable contributes to each principal component. So PC1, let's focus on PC1. We see high positive values of magnesium, zinc, and average price of 0.5, and calcium of 0.35. This means that PC1 is essentially a mix of these minerals with higher average prices. PC2, now look at PC2. Vitamin D3 has a very high positive loading, that is 0.5794, whereas calcium has a negative loading of 0.579. So medicines with that score high on PC2 have higher amounts of vitamin D3 and low amounts of calcium. PC3. So this component has a strong positive loading of zinc and a negative loading of calcium. PC4, this component is most heavily weighted towards the average price, that is negative 0.814810, and magnesium of 0.512. So PC5, the component has a negative correlation with magnesium, that is 0.638, and a positive correlation with zinc, that is 0.566. The loadings can be positive or negative, indicating that the direction of the relationship. Positive loadings mean that the variable increases with the component, while negative loadings mean it decreases. So if medicine has a high score on PC1, we can expect it to relatively be expensive and contain high amounts of magnesium and zinc. So what does this mean? What does all this PCA mean? So PCA helps us condense the data and understand the key drivers. For example, some medicines may be defined by higher doses of magnesium and zinc, which correlate to the price, whereas others may be defined by their vitamin D3 content with a negative correlation with calcium. So manufacturers need to identify opportunities to optimize their formulations of pricing, and also consumers need to make more informed choices based on their specifics and preferences. So now that we have uh, yeah, so now that we have explored the regression and PCA, let's zoom in even further and conduct a unique comparison of the actual versus the predicted pricing of the calcium using optimization techniques. You might be shocked at the results. So uh, let us let me share my screen so that we can go through the Python code that we have done. So welcome back. Now we are diving into a fascinating analysis of calcium supplements and their pricing. Have you ever wondered if you're really getting the best value for money when buying these supplements? Well, that's exactly what we are going to explore. We've analyzed a range of popular calcium supplements, looking at the nutritional contents, things like calcium amount, vitamin D3, magnesium, and zinc. So then we compared these nutritional profiles to their average market prices. This this graph you see here is the result of this analysis. So we'll just look into once how the code runs. So we'll go ahead and run the code. So as soon as the code runs, initially it will download all the required packages. So once that is done, it will ask us to choose the file. So we will choose the file. We have a file called as calcium medicines. This is the CSV file of our data set. We will go ahead and open it. So once that is done, it does all the required calculations, and it displays us the table along with the optimized pricing. So as we can see, uh, on the x-axis we have the different brands of calcium supplements. On the y-axis, uh, you have the Indian rupees per liter. So the red line represents the actual average prices and you find in the market, and the blue lines show the optimized prices. So these are the prices we calculated based on the purely on the nutritional content of each supplement. How did we calculate these optimized prices? So we used a clever technique called as differential evolution optimization. Think of it as a smart algorithm that figures out the ideal weight or value of each nutrient. So you have calcium, vitamin D3, magnesium, and zinc. The algorithm finds the right balance so that the price based only on nutrition comes as close as possible to the actual real world prices of the supplements. So it tried to make these two prices align. So also the differential evolution is a more layman's term. It's like having a term that smart shoppers who are constantly trying to find the best deals by adjusting how much they value each ingredient. So the goal of the optimization is to find a fair price based solely on the nutritional content, ignoring other factors. We'll just go back to the graph. So, many supplements have shown a big difference between their actual price and their optimized price. For example, Calshakti Platina, the red line shows that the actual market price, while the blue line shows, a much higher optimized price. So, uh, potential underlining is the Tayo 60K is another notable example, its optimized price is significantly higher than the actual price, suggesting that it might be underpriced based on the nutritional value. I mean, most probably there might be other reasons for the underpricing of that. So there are price alignments. On the other hand, some supplements like Shelcal show that the two prices are very similar. This suggests that its market price very accurately reflects its nutritional value. Okay, and also we can see, Provical Fort, Ascal Gold, even these have, very similar prices, suggesting that, their market price suggests their nutritional content as well. So, what does all of this mean? Well, for manufacturers, this kind of analysis can help them think strategically about pricing. Are they pricing the supplements fairly based on what they offer? Are they overcharging based on the perceived value rather than the nutritional content? Now, for consumers like you and me, it's useful. It's a useful way to compare value. We can see which supplements are offered more nutrients for their pricing and which might be relying more on the branding or market. It's important to know that other things like the brand name, fancy packaging, and supply and demand can change the cost as well. Don't be fooled by flashy packaging or celebrity endorsements. Always look at nutritional facts, labels, compare the content to price. So now it's crucial to acknowledge that this is a simplified view of the real world pricing is, and but the real world pricing is complex. Factors like brand reputation, marketing costs, manufacturing expenses, and supply and demand all play a role. So this analysis doesn't give us a definite answer, but it does offer a valuable perspective. So, there might be other limitations like bioavailability. We haven't considered how well the body absorbs nutrients. Some forms of calcium or vitamin D might be more, bioavailable than others. Also, the dosage forms, we haven't, accounted for the difference in the dosage forms like tablets, capsules, liquids. These can affect the manufacturing costs and pricing as well. And also the regional price is very important, like here in Karnataka, Tamil Nadu, Andhra, prices can vary depending on where you live, where you buy the supplements from. So we can go back to seeing the graph. So in conclusion, this analysis highlights the potential discrepancies in the pricing of calcium supplements. By understanding the relationship between the nutrients contents and the pricing, we can all make informed decisions. Wow. So we have covered a lot in this video. We've started by exploring regression analysis, seeing how well prices predict mineral content. Then we've used PCA to uncover the hidden relationship between the different nutrients. And finally, we did a head-to-head comparison between the actual versus the optimized prices of calcium supplements. So the overall story, price isn't everything. While there can be some correlation between the price and the mineral content, it's not a guarantee. Always do your research, read labels, and consider all factors before making decisions. So thank you for watching. I hope you found this video helpful and informative. Let me know in the comments if you think about the analysis and you found this helpful. So the data sources of this analysis was collected from the different brands that I mentioned. So I went into each brand, looked into the contents, and then I noted it down. Don't forget to like and subscribe for more data-driven insights. Also share this video with anyone whom you might find it useful. What other supplements product would you like me to analyze? Let me know in the comments below. Thank you.